All right, welcome back, guys. Previous lesson, we discussed how to describe a data set using a single value that represent the entire set data. In this lesson here, we look at measure variation, where sometimes the measure center is not the best way to describe the data set because just because sometimes data sets, two data set have the same mean, median, mode, or the measure center doesn't tell us any different at all. So that's why we have the variation come in. We can describe two different data set in a way that the data values are vary from each other. Here's an example I'd like to start this lesson here. We have waiting times in minutes of customers at a bank, where all customers enter a single waiting line. Okay. And a bank where customers wait in individual lines at three different teller windows are listed below. Carefully examine the data to determine whether there is a difference between the two data set that is not apparent from the comparison of the measure center. So now we got bank A, bank B. Bank A is a single line setup where everyone get in line, one line, and then you go to multiple tellers, I'm assuming. And then bank B, multiple lines with multiple tellers, right? So let's see here. If we were to see there is any difference between the waiting time, let's just check the measure center first. Let's just find out here. So let's say mean, median, mode for bank A. So bank A. And then over here we can say bank B, mean, median, mode. So if you take a minute and verify this, the mean, median, mode for each bank waiting time are the same for both. So if you do the math, you can pause the video and try and do the math here. So you get 7.4 minutes for bank A's, and then you get the same thing over here. If you add up all those numbers, median is the same thing, 7.2 for bank A, and then 7.2 minutes for bank B. Mode, I believe mode is 7.7 for both banks. So from these two data set, we can't really say anything different between these two setup for the two banks because the measure centers are the same for both. So the goal is trying to figure out which setup is better, and I think that's good to kind of talk about that, which is better, which setup is better. Well, the measure center doesn't really give us anything. But if we observe the data more closely, these data values in bank A versus these data values in bank B, we can say something about those waiting time individually. So we can say, all right, single line or bank A, single line setup for a bank teller. Okay, for this data set here, we notice that waiting times, all these data values, waiting times, all these data values here, well, you say that these are pretty close to each other, right? Are closer to each other. Okay, that's just by observing. Multiple lines. Okay, all right, multiple lines. These are the data values here. Will you say these data values here are somewhat farther apart, or the word we're looking for here is the waiting times or the data values. So waiting times, we say waiting times are more spread out or vary, right? So there it is, the word spread or vary. That is measure of variation. Okay, it's the measure to measure the spread of the data set. Okay, so we observe the data value themselves and describe how varied is that data set if the data values are vary from each other, right? So there is the difference. We got one is time are much more close to each other, waiting times are more spread out or vary, right? So that is the difference. It turns out, nowadays, if you notice when you go to a bank, most banks are changing from this here to a single line setup. And it turns out that customer service says that customers are more happier if everyone had the same wait in line versus, if a person wait in line for like 15 minutes to see a teller and then another person walk in randomly and then go see the teller from a different line. Certainly there is a huge variation in the waiting time there. Customers tend not to be happy. If you were that person that took 1 minute to see the teller, certainly you'll be happy. But if the roles were reversed, you won't be happy either. So this is just a note here. We say that we're gonna say banks change from multiple lines to single line to make customer happy. Okay. All right. So speaking of measure spread and vary, how do we mathematically capture that? Because this is it's kind of subjective. It's like, oh, it's kind of spread of vary, but in the math class or in the stats class, we ought to be able to capture that a little more objectively. Meaning, is there a math formula? Is there a way for us to capture that using a value or number so it makes sense? And the answer is yes. So the first measure of variation is called standard deviation. So this saying that it, by the way, denoted by S. So the standard deviation of a set of sample data is measure how much or how far data values deviate or diverge from the mean. So we got the reference point, the mean. So we said the mean is the reference point. Okay. We want to see how the data values deviate from the reference point. So hence the word standard meaning on average, how much the data deviate, right? So standard deviation, the formula, we're not going to discuss how to derive the formula, but the formula is square root the sum of each data value, subtract the sample mean, and then we square that, take all those, add them up, divide by n minus 1. So that's the sample standard deviation. So sample standard deviation. Okay. Population standard deviations is denoted as, the Greek letter S is sigma. So sigma equal square root x minus mu squared over capital N. Okay, so it depends on if our data set is given as sample, we use this formula. If our data set is given as a population, then we use the other formula. Now, to kind of demonstrate how do we do this by hand, if we were to use this here, this data set, I'm just going to write down just the first few steps here. I'm not going to go into detail how to do it. But first, we make these columns, x minus x bar, and then x minus x bar square. All right, so the first data set we have 6.5, 6.5, 6.7, 6.8, 7.1, 7.3, 7.4. We're going to take those data set, those data values, subtracted the mean, and the mean was 7.4. So we said, all right, so 6.5 minus the mean is 7.4, and then take that result and then we square that. So what is 6.5 minus 7.4 here, which is negative 0.9, and then we're going to square that. So negative 0.9 square, what would that be? It's going to be 0.81. And then we're going to do this to all the data values. So we take each data value and then we're going to repeat this step here, repeat this step here, and then we're going to sum that up. And then we divide by how many of the data values are there. Okay, minus 1. So doing by hand, it certainly is doable. It just takes a lot of time. Just imagine if our data set is, containing like maybe 100 data values or more. Certainly doing by hand is not what we want to prefer. So we wanted to use the technology. So I'm just going to quickly go over how to use technology to compute the standard deviation here. So we're going to compute the standard deviation for both of this two data set here. Okay. So we go to our calculator. We're going to go to Stat, Edit, and make sure you clear out your column. Okay, I'm going to clear out. Okay, so I'm going to go ahead and enter bank A waiting times under L1. So we have 6.5, 6.5, 6.5. Oh, I messed up again. 6.5, 6.7. I'm not doing good right now. 6.5. Okay, 6.7, 6.8. 7.1, 7.3, 7.4, 7.7, 7.7, 7.7. So that's bank A. Let's enter the time for bank 2 as well. So these are the waiting times here. 5.4, 5.8, 6.2, 6.7, 7.7, 8.4, 9.3, 10 minutes. I missed one number. Let's see here. 4.2, 4.2, 5.4, 5.8, 6.2, 6.7, 7.7, 7.7. I missed one, 7.7. Okay. So when we compute the standard deviation, let's go back to our notes here. We said that based on the data values, there are more variation in bank B waiting times than bank A. The multiple line setup versus single line setup. So when we compute the standard deviation for each of these two data set here, we're going to expect the standard deviation for bank B or multiple line setup is larger than bank A, which is the single line setup. So we're going to do stat, calc, one variable stats, and then we're going to say let's compute one variable stat summary for bank A or column 1, L1. And that's going to give us the standard deviation, which is the S of x, not sigma S of x. So 0.49 is what we use in here. So we're going to say use technology. Okay. So bank A, bank B, standard deviation is 0.49. And then standard deviation for bank B is 1.81. 1.81. So you see how this is much larger than that, right? Okay. So that's how you use technology to compute the standard deviation. So remember, the standard deviation refers to on average how much or how far the data deviate from the mean there. So if the mean is 7.4 minutes, right? If the mean is 7.4 minutes for both of them, so x bar is 7.4 minutes. So this is saying that on average, a single line setup only has about half a minute deviate from the average waiting time, whereas bank B on average has about 1.81 minutes deviate from the average waiting time. So this one has a high, bank B has a, or multiple line setup has a higher variation among the waiting times. Okay. All right, I'm gonna stop in the first video here. I'll make another video on part 2 on this lesson and discuss range rule of thumb, empirical rule.